For thousands of years, the rhythm of human thought followed the slow pace of the mind alone. Ideas spread at the speed of speech or handwritten letters. Knowledge was limited to what one person could learn in a lifetime, and creation demanded endless repetition by hand. A scholar in 1700 lived in a world of intellect fundamentally similar to that of a scholar in ancient Greece. Everything was manual, local, and finite. But in the early 21st century, in the glowing data centers of California and beyond, that ancient rhythm began to fracture. Humans learned how to extract intelligence from vast oceans of data and scale it beyond anything seen before. We call it the AI revolution, beginning around 2017 with the transformer architecture, accelerating dramatically after 2022 with models like ChatGPT, and surging into 2026 with multimodal giants from OpenAI, Anthropic, Google, and xAI. This event marks the transition from human-only cognition to machine-augmented thought. It is the moment humanity unlocked the stored patterns of centuries of human knowledge and used them to drive the gears of a new civilization. In the early 21st century, a handful of tech nations led the digital world. They controlled global platforms, vast cloud infrastructure, and oceans of user data. More importantly, they sat on literal mountains of compute power and electricity. This single combination, fused with an unprecedented entrepreneurial spirit, would spark a fire that would consume the old patterns of work and forge a new one. To understand how this revolution began, we must look at the pillars that allowed a few companies to outpace the rest of the world. First was explosive data productivity. Decades of internet usage had already created trillions of data points, freeing human attention for higher tasks while feeding AI training. Second was regulatory environments that encouraged massive investment. Unlike many regions, certain nations protected intellectual property in algorithms and encouraged venture capital at unprecedented scales. Third was geographic and infrastructural windfall. Vast renewable energy grids and undersea cables made global compute accessible. Fourth was the computing revolution of the late 20th century, which had created a culture of rapid experimentation and open-source sharing. And finally, the unique mix of high cognitive wages and cheap compute. In leading hubs, hiring a skilled engineer was expensive, but running massive GPU clusters became incredibly cheap relative to output. This created an incentive to build systems that could do the thinking of thousands of humans. Before the large models, there was the content creation system. Individuals wrote articles, coded scripts, designed graphics, or analyzed data in isolation. It was a slow, domestic life, but demand for knowledge work exploded. The world developed a taste for instant intelligence. Initially, no machine could compete with the nuanced reasoning of a trained human. But instead of stopping progress, the limitations forced entrepreneurs to innovate. They needed a way to generate text, code, images, and decisions faster and cheaper than anyone else. The first domino fell in 2017 with the transformer. This simple architecture allowed attention mechanisms to process sequences in parallel, doubling efficiency. But it created a crisis. There wasn't enough data or compute to scale reasoning. The bottleneck remained for years until models like GPT-3 in 2020 stepped forward. This allowed a single system to generate coherent, long-form content. Then came the true turning point in late 2022. ChatGPT, built on GPT 3.5 and later GPT-4, proved that production was no longer a solitary affair. It was now an industrial process. Within months, multimodal models combined text, vision, and voice. By 2025 and into 2026, successors like Grok, Claude, and Gemini produced reasoning finer and more consistent than many humans in narrow domains. The result was staggering. In 2022, global AI investment was in the tens of billions. By 2026, that number had skyrocketed, with single training runs costing hundreds of millions. Silicon Valley, once a modest tech hub, earned nicknames like Computopolis. Cities hummed with the sound of data centers, their skies lit by cooling towers instead of coal smoke. But as the cost of intelligence fell, the human cost began to rise. Quality human work remained superior in creativity and empathy for decades, but AI systems became so productive they eventually undersold entire professions, disrupting writers, coders, artists, analysts, and leaving millions facing uncertainty. While language models were reshaping knowledge work, another revolution was happening in compute. As models grew larger to meet demand, they faced an enemy: energy and hardware limits. Traditional CPUs were too weak. This necessity led to the dominance of GPUs and specialized accelerators. At the turn of the 2020s, early scaling laws showed that more data and compute equaled better performance. These were inefficient by future standards, but because electricity was relatively cheap in key regions, it did not matter. They opened up exponential growth in capability. The true leap came when companies realized separate innovations in efficiency, like mixture of expert architectures and optimized training, could multiply output. Supported by massive funding, these systems used only a fraction of previous resources for similar results. For the first time in history, cognition was no longer dependent on biological brains or slow human collaboration. An AI agent could be deployed anywhere, not just in offices. Compute was applied to everything. It wrote code, diagnosed images, optimized supply chains, and generated art. The invisible army of digital workers grew by trillions of parameters every year. Compute also transformed industries. For centuries, innovation had been limited by human bandwidth, but breakthroughs in parallel processing allowed for much larger models and an explosion in applications. As inference became cheaper, it became a primary tool. New processes such as fine-tuning and retrieval-augmented generation allowed precision at a fraction of previous cost. Dangerous or repetitive intellectual work persisted, but their labor built the platforms, the assistants, and eventually the autonomous systems that would knit global knowledge together. As AI systems grew, the landscape of work changed forever. This was the era of massive cognitive urbanization. People flooded into digital platforms, pushed by automation of routine tasks and pulled by the promise of augmented productivity. Cities of code and data exploded, but this growth was chaotic and unplanned because adoption happened so rapidly. There was not enough policy to build adequate retraining. Workers were squeezed into gig economies or facing obsolescence, living with uncertainty and no safety nets in some regions. Inside companies, a new kind of discipline was enforced. In the old world, work followed human pace and inspiration. In the AI era, work followed model latency and prompts. The system demanded that humans adapt to the speed of algorithms. Shifts blurred into 24/7 availability. Most early impacted roles were knowledge workers, writers, designers, programmers, researchers. Displacement was not new, but the scale made it visible and grueling. Tasks as young as basic analysis were automated, preferred because machines were tireless and cheaper. This created a profound social crisis, leading to calls for new policies, universal basic income experiments, and debates on reskilling. Yet despite the hardship, the AI revolution also created a massive new creator class. For the first time, there was a growing population of prompt engineers, data curators, AI ethicists, and tool builders. These people lived in comfortable digital economies with access to instant tools and global markets. They were the drivers of a creativity revolution where ideas like custom art, rapid prototyping, and personalized education became affordable for millions. As production scaled, the old system of slow collaboration and manual verification could no longer cope. The AI revolution needed a way to move insights quickly and cheaply. The answer was massive expansion of APIs and agent frameworks. First came the age of tool integration. High-profile projects showed that chaining models with external tools was far more efficient. Success inspired agent mania, linking AI to databases, code, and real-world actions. allowing a single prompt to accomplish what once took teams. But APIs were soon eclipsed by the most iconic shift: autonomous agents. Agents were made possible by cheap inference, better reasoning chains, and memory systems. Innovators realized that if you put intelligence on loops and gave it tools, you could move complexity at speeds never seen. The deployment of early agent swarms was a sensation. They linked tasks across domains. Ideas spread at the speed of inference. Employment shifted massively. On global scales, AI was shrinking distance. While improved connectivity had boosted collaboration, the arrival of real-time multimodal AI meant knowledge work was no longer bound by time zones or expertise scarcity. The world was shrinking further. A developer could now orchestrate outcomes with precision unthinkable a generation earlier. For years, leading labs tried to keep core weights secret. Export controls and talent poaching laws emerged, but the fire could not be contained. Companies were eager to expand and other nations desperate to catch up. China surged with open-source alternatives. Europe focused on ethical frameworks. Developing regions adopted at varying speeds. By 2026, the landscape mirrored the uneven spread of electricity in the 20th century. Not everyone welcomed the new age. For many skilled workers, the AI revolution felt like disaster. Coders who spent years mastering languages suddenly found themselves unable to compete with autocomplete agents. This despair led to digital Luddite movements where people protested automation or demanded pauses. Governments responded with regulation, protecting emerging industries while trying to balance progress. In the world of ideas, the revolution sparked massive debate. Thinkers witnessed the acceleration and saw a system of potential exploitation that could lead to inequality on new scales. Others celebrated boundless augmentation, stressing human spirit over machine efficiency. Even the environment pushed back. Massive data centers consumed electricity equivalent to small nations, reviving debates on sustainable compute. Laws began to regulate energy use, and scientists traced links between AI growth and carbon footprints. By the middle of the 2020s, the first wave of the AI revolution had matured. But a deeper wave was coming, one defined not by language models alone but by embodied agents, robotics, and true general intelligence. The invention of scalable reasoning and world models allowed for autonomous systems. Energy-efficient inference opened doors for edge deployment. The rhythm of society became permanent augmentation. Creation became a cultural activity with instant tools offering dizzying arrays of possibility. The world was now connected by real-time intelligence. Looking back, the AI revolution may prove the most important event since the original Industrial Revolution. It promises sustained cognitive growth and lifts material and intellectual advancement. For the first time, idea generation and problem-solving undergo exponential scaling. But it also demands new ideas for managing human society. It creates enormous economic division and shifts gravity toward compute-rich regions. The landscape of our minds will never be the same. The quiet pace of thought was replaced by grid-patterned intelligence and silicon arteries of a new era. The legacy of this moment is embedded in our daily lives. We are the direct descendants of that first prompt that scaled. The AI revolution did not just build assistants, it redefined what it means to think, shifting us from a species that followed the slow rhythm of biology to one that demands the world move at the speed of inference. We have inherited a world of boundless augmentation and breathtaking capability. But we also carry the weight of the social and environmental shadows that acceleration leaves behind. The AI revolution began as a solution and may end by changing more than it intended. Revolutions arrive quietly, and by the time we notice, we cannot imagine life without them. I'm Robin and Slashant Life, watching the present so we can understand the future. Together, we keep history and now possibility alive. See you in the next era.